सर हमें नहीं पता है, लेकिन इसका है। ये बैग किसके है दोनों वाले? कोई पर कंपाउंड करवा दे कुछ। पलटी करी होगा। वाह या तो कुछ जो स्कोर रीडिंग से मर जाएगा तो।
Carminals, an initiative born from the visionary goals set forth by the Honorable Prime Minister of India, Shri Narendra Modi ji. Today, as we have gathered here at BPIT as a part of nationwide series of seminars aimed at discussing and embracing the metamorphosis that will pave the way for a developed and empowered India by the year 2047. In the pursuit of excellence and in alignment with the Ministry of Education, Government of India, and the All India Council for Technical Education (AICTE), we have embarked on the journey to just discuss and deliberate upon the transformational changes that have laid the very foundation of Viksit Bharat by 2047, a developed and progressive India envisioned by our revered Prime Minister Shri Narendra Modi ji. This vision, a clearly call for the developed India, resonates with the aspirations of every citizen and echoes the ideals of a strong, self-reliant and prosperous nation. In this moment, as we gather for an enriching session, let us remember the essence of knowledge, the power of learning, and the first week for truth. For it is through education that we enlighten our minds, expand our horizons, and transform our lives. My heartfelt reverence to Goddess Saraswati, the embodiment of knowledge, wisdom, and grace. May she bestow upon us her blessings and guidance as we embark on this journey of learning and growth. I'd like to welcome Octave, the Musical Society of BPIT, to grace us with their rendition of the sacred Saraswati Vandana, honoring the embodiment of knowledge, the goddess Saraswati. And now, in this vital moment of our gatherings, we stand on the threshold of the round lighting ceremony, an embrace of knowledge, enlightenment, and earthly pursuit of excellence. Today, as we gather, we unite to recite the star, symbolizing the invaluable wisdom bestowed upon us by our Stereo. Before we proceed, let's honor the significance of this act. The flickering flame represents not just knowledge, but the enduring spark within us, ignited at the beginning of our knowledge at Bhagwan Parshuram Institute of Technology. I would like to invite the honorable dignitaries to do the honors and light the sacred lamp symbolizing our collective quest for enlightenment. The air starts with the spirit of progress today. Our institution is honored to host the Amirtkaal Vimarsh, a platform for intellectual discourse and visionary conversation. Ladies and gentlemen, it is with immense pleasure that we now welcome the distinguished Mr. Deepak Soni, Head of 5G and Strategic Network, Evolution of MOAI, Ericsson India Private Limited, as an esteemed speaker today. May I kindly invite our Honorable Executive Director, Sir, Professor Vaidikor, to extend a bouquet as a token of gratitude. Thank you, sir. May I now request our Honorable Dean Academics, Professor Ajay Kaushik, sir, to represent the sampling to our distinguished guest, Mr. Deepak Soni. Thank you so much, sir. We come together not just as students, teachers, or administrators, but as architects of the future, eager to explore the transformations that will propel our nation to new heights. I'm delighted to have everyone gathered here for an enlightening session on the future trends of 5G or B5G, exploring benefits and challenges. Our discussion will unfold in two parts. First, an engaging talk on the topic, followed by an interactive question and answer session. Ladies and gentlemen, it is my honor to introduce our distinguished guests for today. Mr. Deepak Soni, the head of 5G and NS Strategic Networks Evolution at Ericsson for Southeast Asia, Oceania, and India. With over 2 decades of rich industry experience in mobile networks and various technologies, Mr. Deepak Soni holds a pivotal role in steering the evolution of radio networks and new technologies within the dynamic market. Mr. Sony's purview encompasses driving the evolution of radio networks and pioneering new technologies in this expansive market area. His relentless pursuit involves propelling high initiatives, empowering telecom operators, and specializing in radio access technologies. A visionary with an unparalleled ability to innovate, Mr. Deepak Soni is renowned for his out-of-the-box, consistently delivering cutting-edge solutions that redefine industry standards. Please join me in welcoming Mr. Deepak Soni to share his whisper of knowledge and enlighten us with his visionary insights that continue to shape the future of mobile networks and technology advancements. Let's welcome Mr. Deepak Soni to the stage. So, good morning, good afternoon, all. So, thank you, Mr. Chairman, Professor Rajiv Sharma, and other faculty over here and students for calling me here. Today, I will take you through, how the technology is evolving from 2G to 5G and even beyond 5G. How the landscape is about in the industry. So this is how we started. When we say we, I am talking about Ericsson. We go and we started with 1G, and 1G was in the time frame of 70s and 80s. Then we migrated to 2G, which is 80 to 90s. Then we migrated
3G, which was 90s typically, and then 4G was early 2010, and 5G was all about 2010 to now. And if we talk about specifically 5G, we uh, India got 5G almost similar times last year, and we are still in a process of deploying 5G in India. And I believe most of you might be seeing 5G icons in your phones, currently when you're sitting here. So it's all about migrating to 1G to 5G. And what is the difference that each G is bringing? So when we talk about each G is more spectrum efficient than the previous G. When I spectral efficient means it churns out more bits per megahertz basically to the previous, which makes operators, which is kind of currently Vodafone, Idea, RGO, and Airtel in our country, to have more efficient networks and bring out more money out of that. So this is how the evolution happened. 1G was all about voice, 2G was all about voice. Then when we entered 3G. In 3G, we had voice as well as data, but it was in kbps basically. Then we migrated to 4G. 4G, we had data in terms of Mbps, and now with 5G coming into picture, along with the voice, we have data in terms of Gbps basically. So we evolved from kbps to Mbps and now Gbps. And in future, we will see that this Gbps will get into the terabytes and all those things. So this is how technology is evolving. And now we have started talking about even 6G, but 6G is still at a very native stage. From a standards perspective, we have just started talking. We have a 3GPP, which is a governing body globally, basically, which decides what are the technical specifications for each technology. So in 3GPP, we have started talking about what should be the framework of 6G. So nothing is fixed now. So the first meeting of in WRC for 3GPP will be happening early next year, where all the bodies, which includes regulatory, which includes vendors like us, which includes operators like Geo and Airtel, they gather globally and they try to debate and discuss what should be the framework of 6G or any technology coming into picture, and then they start working on the each work item. So this is how the technology is evolving, how standards are evolving. Okay. So what I just told you that 1G was only voice, then we migrated to 2G, which was into kbps, then 3G again Mbps, 4G again Mbps, now 5G. We are talking about throughputs or speeds up to 20 Gbps, which is an enormous speed. And most of us will be remembering that when we used to send a mail on 3G, it was next to impossible to send the mails on 3G network. But now you can do 99% of your stuff with your phone, sitting at your home or in your car or in your office. So this is how technology is bringing a revolution, I would say, in the industry and for consumers like us and for industries which we call it B2B, so business to business. So this 5G technology is not about B2C. So B2C is business to consumers and B2B is business to business. So 5G is also applicable for the industries. It is beyond the consumers, and currently 5G is targeting some of the developed nations. If we talk about like Europe and US, they have done automation through 5G in their factories, in their processes, and many of the factories globally are working on 5G autonomously, and they are using a lot of AI, machine learning, all those stuffs to bring in efficiencies in their production. Name a few industries, the major benefit which a certain industry can get out of the 5G is basically the manufacturing industry. Second industry is healthcare industry. Third industry is education. You think about a scenario that there's a remote village basically where children have to come say 100 kilometers or more than that, travel daily to study for higher educations. Now with 5G coming into picture, they can remotely, learn new things. They can take new courses and upskill themselves at their home with this technology. So it is being it is revolutionizing, different verticals across the industry. This is about the 3GPP. So the first 3GPP release was, R99 release, which started somewhere with WCDMA. We called it 3G also. Then the first release for 5G was basically release 16. Till 3GPP release 15, it was only 4G, but beyond release 15, we had 5G, and now if we talk about the current release, we have release 16 already out, and we are working on release 17 and 18. So this is all the technology. Currently you are talking on phone or browsing your data on your mobile handsets. All these are happening through this 3GPP, which is a governing body which decides what should be the framework for each technology, and accordingly, all the vendors and the OEMs work accordingly to come out with their products, and they have to basically comply to all the basic requirements of these 3GPP specifications. Why it is required? It is required because there has to be a common thing or common fabric across the industry. Otherwise, think about the scenario: you are sitting in India, and if there are no standards, then probably if you roam out, say you go to US or Europe, your phone will not work. So to bring in uniformity, 3GPP is playing a very vital role, and India is also, driving various specifications. Specifically now, our Honorable Prime Minister has launched a 6G program also for India. Even for 5G, IIT Chennai was spearheading the 5G test bed. And we as a Nixon also established a center of excellence in IIT Delhi, I think 4 or 5 years back. And our main aim was to develop the use cases for India in India. Basically, some of the use cases which are relevant for US market or other markets may not be relevant for India because geographies are different, requirements are different, people are different. So depending upon that, we thought of that we should set up a center of excellence in India, and we should develop the use cases for India by India basically. And now Modi ji has started the 6G program, and we will say similar activities coming into future for 6G also. Then important thing is what 5G technology brings in. So previously, I don't know how many of you know that all these phones work on a wavelength of frequency basically. So to run these network, Government of India options a spectrum, and those spectrum basically enables how our mobile phones should work and how our phone should work with the voice and data. So with 5G coming into picture, it brought in new frequency bands. Previously, we used to have low bands like 900 megahertz, 1800 megahertz, 2100 megahertz, and 2600 megahertz. When we talk about 5G, it is talking about the mid band, which is probably 3.5 gigahertz and even 28 gigahertz of band. And majority of deployment, if we see globally, is happening on 3.5 gigahertz of band. So 5G brings in the higher frequencies, and these higher frequencies come with the wider carriers basically. So the second point is wider carrier. So current frequencies which operators have is in the range of. Okay. So the current frequencies which operator globally have in low bands is in the range of 10 megahertz or maximum 15 megahertz in FDD band, and around 30 to 40 megahertz in TDD band. So with 5G coming into picture, the bandwidth of the spectrum increased from 40 megahertz to 100 megahertz, and even for the millimeter wave, it is in the range of 800 megahertz to 1 gigahertz. So it brings more spectrum. How it correlates to common men like us, when we have a wider, carriers, then we are able to get larger throughputs or higher throughputs. That's why in the evolution story you have seen that we moved from Mbps to now Gbps. So with wider carriers and with 6G coming into picture, we will get into beyond Gbps also into terabytes also. Technology you see here is advanced antenna techniques basically. So previously, you must have seen towers on the rooftop and all. There's an equipment which is being installed there. Previously, with the 2G, 3G, and 4G technology, what we used to have a radio, which was an active element on the towers. Along with that, we used to have a passive antenna, basically. Now with 5G coming into picture, we have passive MIMO, which brings in more efficiency to the network. And what passive MIMO does it that uh, we integrate both radio and antenna together so that we can bring in more efficiencies, and by that we can have more bits per megahertz. So that is the benefit of the advanced antenna technologies, which we call as massive MIMO. The most important point is that uh, operators can really enable 5G on their existing hardware. So they don't need to, bring in a new hardware. So whatever existing hardware these operators have in their network today can be upgraded to 5G just by a software. So there is no change of hardware required in a particular frequency band. So just to an example, if an operator, say Airtel, is using a frequency band of say 2300 and it is running 4G on that, so by just software, Airtel can enable 5G on their equipment just by software. So no change in the hardware. And and the last part is the architecture evolution. So 5G came with the two kinds of flavor. The flavor one was non-standalone architecture, and the flavor two was standalone architecture. The difference between both the architectures was that in non-standalone we require underlying edging technology to run 5G. So that was the flavor one. The flavor two, you don't require any underlying IT technology to run 5G. So the real 5G is the standalone 5G. NSA was an interim solution from the industry to run 5G. So if in NSA mode you have to run 5G, you need to have a LTE network for sure. Without that, in NSA mode, 5G will not work. On the contrary, when we talk about the standalone architecture, there you can run 5G even without having an underlying LTE layer. So that is how the ultimate goal of 5G was. And what 5G SA architecture also brings in is end-to-end network slicing, which is also a big buzzword around the industry nowadays. By doing that network slicing, you can guarantee the quality of services, for a particular application. You can have multiple slices in your network, which can be allocated, say for one slice for mobile broadband, one slice for fixed wireless access, one slice for UNLCC kind of applications, other slice for L4S kind of applications. So different kind of slices can only be enabled on standalone architecture. Another thing which is important is that we are able to get latencies, end-to-end latencies with SA in the range of 10 milliseconds. Whereas with non-standalone it was in the range of 30 milliseconds. So for URLCC kind of application, it is very important that we should have a standalone network. Also, I am talking about the radio perspective. If we go to the core perspective, basically in NSA you can upgrade your existing core which you were using for your 4G network to enable 5G. But in case of SA architecture, you require a 5G core, which we call as a 5GC, and that is kind of a network function virtualized node. And all the functions in the core network you can virtualize, and you can enable the standalone architecture. So these are some of the things which 5G brings in, which differentiates 5G from 4G basically. So these were the expectation from the industry on 5G basically. When we talk about the peak data rate, so industry was expecting that the peak data rate for 5G will be in the range of 20 Gbps. User experience would be in the range of 10 to 100 Mbps. Currently, in 4G, the typical networks which are being designed are for the user experience of 3 to 5 Mbps. The reason is that we have very less spectrum in 4G, but when in 5G we have 100 megahertz of spectrum, then we are talking about speeds up to average user throughputs up to 100 Mbps. Also, from a spectral efficiency perspective, 5G is almost 3 times more spectral efficient than 4G. When I say 3 times more spectral efficient means that if you have X number of resources in 4G, the amount of data that 4G can carry versus 5G is almost 3 times that of 4G. So it is more spectral efficient, almost 3 times. Then, with respect to mobility, you know, 5G can support our mobility up to 500 kilometer per hour of speeds. 5G can sustain the link budget basically. Then, if we talk about the connection density, everybody must have heard about the IoT Internet of Things. So when we have sensors everywhere, then 5G technology we can have around 1 million sensors per square kilometer. That is what capability 5G brings in for massive IoT kind of things. Things about have sensors in the air conditioning, you have a sensor in the projector, you have a sensor in your cameras, laptop connected on the network. So 5G brings in, you can connect up to 1 million sensors per square kilometer with 5G coming into picture. Then, in terms of energy efficiency, 5G is almost, 50 to 100 times more efficient than the existing 2G, 3G, 4G technology. Then, from capacity perspective, it's more because you have more spectrum available in 5G. That's why it stays out of the 5G network. And then in terms of reliability, 5G 5.9 reliability. So that is very important thing at least for the ULCC kind of applications where reliability is more important thing about the scenario where somebody is doing a robotic surgery and you don't have the reliability in the network. Doctor doing something gets all of a sudden something goes off. Or take an example of an automotive industry where everything is being done on the 5G network and due to reliability, something goes down. Think about how much loss in the production will happen at that point of time. So 5G brings in 5 nines reliability, which is very important thing. In terms of latency, I talked about that 5G brings in the latency in the range of 1 to 10 millisecond. Whereas in existing 4G networks, we used to have even latency up to 50 millisecond or even 100 millisecond, depending upon what kind of applications a user is using. Uh, Also, what we expected from 5G is about the battery life of these IoT sensors. Because if we have, say, sensors everywhere, think about the scenario if the battery life of these sensors is not high, then how much difficult it will be to replace the battery, say, every month or every 2 months. Sensors everywhere in the field to replace the battery every month is a cumbersome job. So expectation from the industry for the massive IoT sensors what the battery life of these kind of sensors should be in the range of 10 years. And definitely the most important thing which is on our mind also and the CSP mind is security. So there are a lot of intelligent algorithms and security mechanisms built in 5G, which takes out the security concerns from the operators and the consumer minds, basically. So this is what is expected. Some of the use cases uh, we have which 5G can enable is first of all is we can categorize it to four parts. One is enhanced mobile broadband. It's all about whatever you are doing on your mobile, ranging from getting the higher bit rates and all. Second use case for uh, 5G is FWA, fixed wireless access. Currently, all of us are having connectivity at our home through optical fiber cables, and then they do a cabling at your home. They place a router basically, and sometimes that cabling doesn't look nice. And secondly, if we talk about specifically about India, the fiber penetration in India is just 35%. There are 65% of the India which needs to be connected, and the Modi ji's aim connect the digital India. How can it fulfill? So FW is a unique use case by which we can, utilize the existing EMBB network, and we can use CPs, which we called as customer premises equipment. Those equipment can be placed at your home. Just plug in the power, just insert a SIM card, and you have a broadband connectivity at your home. So no cables required. The reason is that the cost of laying fiber cable is very costly. So from a business case perspective, if we see the fiber operators which we have, they don't see any business case beyond the urban areas to lay fiber in suburban areas or rural areas. The reason is the business case only flies when you have a higher household density per square kilometer. And if you move from dense urban to urban area to suburban area and rural area, the household density is not that good. So the business case of laying fiber in suburban and rural areas goes off. And then FWA comes into picture for these kind of areas where you have a sunken cost already on your mobile broadband network, and you can enable basically the broadband connectivity without laying fiber. So if we have to cover, say, rest of the India in next 4 5 years, then it is a very good solution. And recently, everybody must heard in the media, Mr. Ambani is talking about connecting 200 million homes on broadband, and out of that is, his he is thinking about that 100 million households will be enabled through FW. So this is a huge number. Currently, the developed nations, which have launched 5G till date, it's almost 2.5, 3 years when 5G first hit the US, Japan, Korea. So it has been 3 years till now. 100 million FW subscriptions are not there in those countries, but we are talking about only Geo talking about 100 million subscription, and Airtel also talking about around 50 millions of subscriptions. So India alone, 150 million subscriptions on FWA is a huge number, and we can bridge the digital divide between rural India and urban India by 5G through FWA. Then the third use case, what we see is basically a massive IoT or massive machine type communication, and the fourth is critical MDC or critical machine type communication. So, and these are some of the examples which you can see for different kind of use cases. So this live TV, event platforms, on demand, anything, all these get into the category of mobile broadband basically. Then if we talk about, autonomous vehicles, connected trucks, connected cars, all these get into kind of a ULCC kind of use cases of 5G. Similarly, critical service and infrastructure control like public safety, mission critical, and mission critical utilities. This also comes under the critical FTC part of the 5G use cases. Uh, so and This one, which is about sensors, about the agriculture, smart buildings, consumer and utilities, this comes under the review of massive MDC. So typically, 5G use cases are distributed into four categories. So you can have different use cases in these categories, depending upon what kind of application we want to handle. So I will not touch upon this. We have done this. Now I will talk about what is the potential of 5G with respect to B2B basically. So B2C, we are the consumers, but 5G is not only about consumers, it's also about the business. So we have around 13 billion C potential in India, which we can target through 5G in different industries. And some major industries are energy and utilities, public transport, manufacturing industry, healthcare industry, and public safety. So these are some of the industries. If I So these are some of the industries which we see a huge business potential, a potential of 13 billion USD in India in next 4 to 5 years, and all these operators will be targeting these industries and will be able to monetize 5G. Okay. Then I will touch upon the spectrum parts. So these are the spectrums which we have in India currently. We have the low bands, which we called as N28, which is a 700 megahertz of band. Then we have N3, which is 900 megahertz of band. Then we have N, which is 1800 megahertz of band, and then we have band A, which is 2100 of band. And then existing, we have the midband, lower midband, which we called as N40 and N41, which is 2300 and 2600. So these were the bands which were till now used for 4G. But now with 5G coming into picture, there are new bands which we called as N77 and N78. These bands are applicable for 5G in India. Similarly, this is a millimeter wave, N257 and 258, which are applicable for millimeter wave in India. And the last year auction which happened in India, we got this N78. In total, N78 in India was around 370 megahertz of band, and in N257, which is millimeter wave, India auctioned around 3.5 gigahertz of bandwidth during that. Uh, Both the operators, Airtel and Jio acquired 100 megahertz in N78. Uh, Even Jio acquired 130 megahertz in some of the circles. We talk about N257, Airtel acquired 800 megahertz of band in N257, and Jio acquired 1 gigahertz of spectrum in N257, which is millimeter wave. So 90% of deployment, whether it is India or abroad or any country globally, the major deployments are having on N78, which is midband. And there is a reason, when there are pros and cons for each spectrum. If we talk about starting from low band to mid band to high band, low band has the best of the coverage. Penetration is very good for the low bands, but as we move up, the penetration, the propagation properties are not that good, so coverage shrinks. That is the one part. But when we move from low band to high band, our bandwidth increases. In low band, typically FDD bands, as I talked earlier, also we have 10 megahertz or maximum 15 megahertz of spectrum in each band per operator, not beyond that. But when we talk about, say, mid band, we have 100 megahertz of spectrum per operator. That is a huge amount of spectrum, and then we are talking about N257, where we are talking about in the range of 800 megahertz to 1 gigahertz of band. So you get a large bandwidth. Large bandwidth turns into more throughputs for consumer, and also for critical applications, we can increase the subcarrier spacing of the channels, and that's how we can achieve the low latency in the higher bands compared to the low band. But typical channel spacing in 4G was 15 kilohertz, but now 5G coming into picture, we can go up to 30 kilohertz, we can go up to 60 kilohertz, we can go up to 120 kilohertz and even 240 kilohertz. And also the modulation, we can go up to 256 QAM, we can reach up to 256 QAM with 5G. Typically, with 4G, it was just about 164 QAM, but now with 5G coming into picture, we can have higher modulations also, which gives more efficiency. So this is, I have talked about, so I will not touch about already. So we can, commitment, we can get peak speeds up to 1 Gbps with 100 megahertz of spectrum, and on millimeter wave, we can get up to even, 4 Gbps of speed with the 800 or 1 gigahertz kind of spectrum. So this is typically, to give you an idea what are the different areas where Ericsson has a play, basically. So if you see from the northbound, node, we have a 5G core, then we have a 5G radio network access, 5G transport, business and operation system. We have cloud communications and network APIs that we also work very closely with the operators on the managed services. We have mission critical communications that network automation and artificial intelligence, private networks and wireless WAN. In India, for private networks will be enabled through operators only. Many countries in US and Europe, they have a separate license for the private 5G. But in India, government has not allocated separate license to the industries. So industries will be enabled through operators like Vodafone, Airtel, and Jio. There is no separate license in India for private. When I say private networks, it can be a particular industry, it can be an education institute, it can be a healthcare hospital. So we have enabled till now in India, we are working with various operators and we are trying to enable, 5G in some of the mines with, uh, you know, uh, in Northeast. We are also working with some of the operators in building 5G private networks at the airports. We are also working with some of the leading vehicle manufacturers like Volvo. We are working with them to how to automate their factories. And for your information, we have 5 factories across the globe, and 2 of our factories are fully autonomous. Fully autonomous on the 5G network. One is in Sweden, and other is in US. So there is no human, touch in those factories. Everything is automatic on enabled by the 5G network. So this is how we are, adapting the technology ourselves before we are going to the market and selling those to our, operators or the private network operators. So also I would like to, mention here that we started the 5G rollout in India in October 2022. And currently, we should be very proud of that. The India network is the fastest network in the globe. We rolled out around 350,000 sites in a time span of 1 year on 5G. That is a humongous number. That is a big number which only a country like India can achieve. So we surpassed China, we surpassed the US, we surpassed Korea, we surpassed Japan, which started their journey 3 years back. But within 1 year, we are number one with respect to the 5G deployments in our country, and similar pace is still going on. We probably in Q2 2024, we will have around 450,000 sites. So around 1 lakh more sites still to go on 5G. So this is how we are doing 5G deployments in India. So this is a glimpse on what both of our operators are doing with respect to 5G. Uh, Vodafone Idea took the spectrum, but they haven't rolled out 5G till date. They have some issues within the organization. But the difference which I will show you is that in terms of architecture, whether it is Airtel or Jio, they are having a different strategy. So Airtel started with a non-standalone architecture, and Jio started from the day one standalone architecture. Uh, the Airtel network is purely on 100 megahertz of N78, whereas in Jio we have 130 megahertz of N78 plus the low band, which is 700 band 10 megahertz. So Geo is operating two frequencies currently on a standalone mode. One is 700 and other is a mid band. The value which they get with 700 is that they are getting a better indoor penetration with this 700 band, and they are able to do a coverage extension of the mid band by using this spectrum. So currently, with respect to the pricing strategy, both the operators are not charging any premium when they have introduced 5G in the network. So they are charging the same tariffs from the subscribers which they were charging on 4G. And the capex spend is around 11.5 billion USD has been spent by Airtel, and around 25 billion USD has been spent till date by RGU in deploying the 5G network. So I think we should be very proud of how we are rolling out data. And this data is not Ericsson specific. This data is on the Department of Telecommunication sites. They are publishing this data every 2 months. What is the progress of 5G deployment? So you can go and have a look how things are happening with respect to 5G. Now, I will talk about what is 5G, 5G advanced and beyond 5G. So in 5G, we were talking about enhanced mobile for broadband, massive and mobile type communication or massive IoT, ULCC. So in 5G advanced, we will be talking about capabilities which are beyond eMBB, massive MDC, and basically ULCC. And there is a lot of thinking going on. What should be the candidates basically for 5G advanced or 6G? So 6G is still a long shot because I told you that we are just talking about should be the candidates or what are the thoughts from the operators, what are the thoughts from the industry, and what are the pain points currently in the industry, and how should we resolve those pain points, what should be the items that should be incorporated as study items in 6Gs. But for 5G plus or 5G advanced, we will have better mobility procedures, we will have better algorithms, we will have better user experience when we talk about 5G advanced compared to 5G. So there is a slight difference, but there is not much difference. But yes, 6G will definitely bring in a massive leapfrog when it comes to technology. 6G will be less for B2B, sorry, B2C. It will be more for B2B because there will be talking about more about creating a fabric between a compute and the connectivity layer so that we can have artificial intelligence, machine learning, you know, everything, incorporated on that end to end. We are talking about X to X in 6G. So what is X to X? Then everything will be connected to anything. So you are sitting, you will be connected to your fans, files, AC, everything. Your cars will be connected to the car behind you, car in front of you, car inside of you, on the left of you, right of you. Your car will be talking to the poles, electric poles. So we are talking that kind of scenario when it comes to 6G. But still, 6G is far off. We are still discussing what will happen, what should be the candidates of 6G. So we have to wait, but these are some of the action items which industry is thinking about safety. It can be Internet of Senses, as I'm telling you that we will have sensors every. The second, thing will be connected intelligent machines. Currently, you see that uh, some of the factories they are using automated guided vehicles, but somebody is operating that manually correct it. But when 6G will come into picture, then these automated guided vehicles will talk to each other. And depending upon that, they will take actions themselves by having, machine learning, artificial intelligence, analytics. They will run analytics, on the go, on the fly. It's not that now you're capturing some data, you're sending to the data center, and then somebody is crunching and making sense out of that data, and then based upon that, we are taking a reactive decision. Now, decisions will be taken proactively in real time when we talk about connected intelligent machines. Then we will be talking about digitized and programmable of interactive 4D maps, precision healthcare. It can be robotic surgery and all those things. Uh, then we are talking also about as part of 6G connected sustainable world, because currently the carbon footprint lot of carbon footprint, and we as an industry are dedicated and really seeing how we can bring in efficiencies in terms of the power consumption, in terms of bringing the carbon footprint down. So 6G will also have one of the action items about sustainable world, where we will see how we can bring in efficiencies in terms of power consumption, in terms of reducing the carbon footprint and all. So these are some of the action items with which we are thinking about, and with respect to some generic trends which we see is that we are seeing industries a lot of talking about generic hardware, which we call as a openness basically. Conceptually, this is a very good concept, if you ask me. Any hardware, anybody can put their software on that, it would run very fantastic. Probably we'll have efficiencies and cost, but probably think about a scenario that I am making a software on my specific hardware. I am implementing some algorithms, some analytics on top of that. Then those benefits, when we talk about openness, will go away. The efficiencies which I bring in today with my specific hardware or with my specific software, when I try to get into a generic off the shelf hardware or software, then those efficiencies will go down. There might be interoperability issues also, which what happens in the industry now that a software guy will say that it's a hardware guy will say it's a software problem. So those kind of problems will come, but definitely I'm not saying that will not happen, that will happen, but as an industry, we need to really see how I can freeze out all these challenges before we really hit upon the generic hardware kind of things. A lot of vendors, particular to telecom, have been talking about the open RAN, open core cloud, and all those things since many years. From a core perspective, yes, it's happening. People are doing cloudification and all. Google and other companies, Facebook, they are working on the cloud. They are hosting a lot of company data on their clouds. But when it comes to uh, open RAN, uh, they have done trials, but to be very frank, most companies are not successful till the we are working, we are also part of the open and we are not saying that we are not in favor of open and we are working on the open and there are challenges, so we need to solve them. Then open source, components is that industry is also talking about. Industry is also talking about the cloud, which I already talked about. So continuous evolution, whether it is DevOps or any other new technology, they are also talking about that. Integrated AI is also part of the 6G work items, where currently what is happening is that we have some process going on. On top of that, we put artificial intelligence, analytics, and machine learning all together on top of that. But now with the 6G coming into picture, we will have an integrated AI already inbuilt in the system. So we need not to bring in another system for the artificial intelligence or machine learning or analytics on top of that. Then Then we are also talking about the internet evolution where we will have for some of the applications like saying that we will have sensors everywhere. So we need to have edge computing also, uh, at various places. Currently, if we talk about the networks, we have one or two data centers. Say for an operator like Airtel, we have only two data centers for the whole Delhi NCR. But when we have sensors everywhere, we have connected cars, we have everything. Then we have to bring in these compute capabilities to the edge, and we call it edge computing. So those kind of things will also come into picture, and industry is working on that, and probably we will see it having as a reality in coming 3 to 4 years for sure. So again, some technology areas. So we will have joint communication and sensing, embedded device everywhere, trustworthy system, network compute fabric, cognitive networks, network adaptability, segment connectivity, extreme performance and graphics. We have already talked about. This will what we will see as our future technology areas, which will be coming as part of us. So I think we are here to create the connections that were unimaginable possible. We are connecting the world. So any questions, any reflections around that? Please be open to ask. Any questions around? Yeah.
So like you was talking in layman speak, we know a lot about the modern 5G and how 5G is hello, this like this, the super will be reaching six kilos. Very one is knowledge, and there are other fields in which you find. In actually one of the specialists, it is saying it was following. What is the problem was intention? What especially in the night dark, that is causing the unpreserved. What is that? What's the and second is could it be possible or still the mission is with an element to share race?
There are two questions. One is about the health hazards of this telecom networks or the towers which we have on top of the buildings, and second is about the collaboration. So, I will answer the first question as uh, all the international, like ITU, 3GPP, they have laid down the EMF restrictions or EMF regulations for all the countries. And the similar regulations has been guided by the Department of Telecommunication and their wing, which is TRI, which comes out with all the uh, technical documentation or technical specifications. So all the operators have to uh, radiate within the specified EMF limits, and try also, on a periodic basis, they do audit of each site to ensure that whatever EMF specifications they have, you know, mentioned in their guidelines, all the operators are following those guidelines. So that is one thing. Definitely, if the operators are radiating beyond that guidelines, it can be harmful for the youth, but all the operators ensures that they don't cross that stringent guidelines and radiate within those specific parameters laid down by the ITU or TC or PRI or DOT. Regarding the second question about the collaboration, I think I can't answer this right now. There are a lot of things which we need to talk, deliberate, and discuss. So that can be a potential areas. We do with the some of the IITs. you can be part of that because you can understand there are various colleges across India. So it is very difficult to get into every college and do some kind of collaborations. What currently, uh, maybe I think last month around 27th, we made a uh, announcement that we are collaborating with the IIT Chennai on the 6G part, and we will be working with them on artificial intelligence, machine learning, and 6G coming in the future. Because 6G is still too early for any industries because we have rolled out 5G last year. So the lifespan of any technology is about 8 to 10 years, to be very frank. So we started 4G around in 2000, and now we see that there are a lot of things which we need to extract. There are a lot of juices which need to extract from 5G. The early test bed of 6G will come into somewhere in 2028, 29 because specifications are still not there. We have to work on specification 3, 4, 5 years. It will take to work on the specification, come out with a early test bed, which is 28, 29, and then probably China is committed to roll out 6G around the time of 2020. So we can discuss things how we can collaborate with the existing engagements which we are going on in different academies. Previous to that, we had one center of excellence in IIT Delhi also for mining and all. So we can talk about and think about how we
Do you have any other question? Yeah, can you pass on the mic to the
Good morning, sir. So my question to you is that just now you told us about 6G. So how far off into the future are we looking at at a ready technology that has high speed, high compute power, and that goes hand in hand with the sustainable development goals set by the United Nations and the Indian government? As a representative of Ericsson, sir, how would you say like how far off we are from that goal?
see some of the things that we are already targeting with 5G. Yeah. So it's now depends upon that. What is your definition of high speeds or high compute? Because the applications which are currently available in market for those kind of applications, we already have the capabilities and the technology available. But yes, for some of the things like autonomous vehicles or remote surgery, we are still far away. One is in terms of the infrastructure. When I say infrastructure is not the telecom infrastructure. Infrastructure means of that the country infrastructure. So in Europe we already have the autonomous. But you think about that a scenario of India where we don't even as a human are not able to do a lane driving at all. Uh, Whether in those kind of countries without a basic infrastructure, whether we can have a autonomous vehicles, no, that is not possible. So I think as a country we need to or different countries depending upon their maturity and what kind of maturity level they have to really see first they have to build up the basic infrastructure, then on top of that they have to build the digital infrastructure, and then on top of that all these use cases and applications will come into picture. But believe me, 50% of the things we can still address with 5G. Even with 4G, we had a narrowband IoT, for massive IoT kind of things. 4G was also was able to deliver, all the things. But with 5G, we can have, as I told that we can have more density of devices or sensors per square kilometer when it comes to 5G. Also, the UNLCC kind of applications or low latency kind of applications we can have. Edge computing we can do still with 5G. But yes, with enhancements, what we will see is in 6G is that artificial intelligence, machine learning, everything will be embedded together and working together as a cohesion. It's one machine. Now everything is working as a separate island. So I am the data, but somebody else is doing the churning of data and taking out the useful information out of that, and based upon that, taking the actions. But now, if we have to do real time actions, then probably all these machines or all these islands have to work together.
Any other question? Yes, sir.
Good afternoon, sir. My question is how can we as faculties contribute to the new technologies?
Come again, please.
How can we as faculties contribute to the new technology?
Okay. So I think currently, if you really ask me, there's a lot of information going across the internet. So there are a lot of courses which are, being developed by, different universities and all. So what we need to do is, and also there are different conferences and industry forums. What is important is academia and industries are not working together. That is the biggest problem in country like India. So we need to really bridge the gap. The conferences which we have, conferences from COI. We have this IMC, which is an Indian Mobile Congress. Last month we had in Pragati Kadar. That is the biggest telecom event after Barcelona. So I don't think so. How many of you visited that? So I don't. Maybe a person, 1%, 2%. So you should encourage yourself also, you should encourage your students also to be part of all these forums, all these discussions, because when you go there, then you see what is the gap between the academia and the industry. And what, to be very frank, what I had studied in my college, nothing is coming handy to me in last 24 years. That is the truth. So we need to, really, and at that point of time, the limitation was that the information was not there. We used to only follow the books which were there, but now there are a lot of things which on YouTube, on various forums and all. We should really go and study, see the videos, attend the conferences and all. That will really help us, and that will give you an alignment that what are the industry needs, and accordingly you can try to look at the what you are teaching to your students. You can bring in more industry experts also, maybe once in every quarter, or to give expert lectures, so that students know what the demand of the industry, and accordingly they should prepare themselves. And when they go out of the college after 4 years, they should be able to really talk about what is going on in the industry. Otherwise, I see, we also take a lot of pressures. They are not even aware what Ericsson does or any other industry does. They just know the buzzwords, artificial intelligence, machine learning, analytics. Beyond the buzzwords, they don't know anything what is happening in these companies. And they know that they give a good salary and all. That's all. But there is a lot of things beyond that. Believe me, if you have to be successful, whatever you are studying in your college, beyond that, try to do a lot of courses. There are free courses also, there are paid courses also. You don't want to get into the paid courses, but you can do free courses, and that will definitely give you a edge when you go out of the college after 4 years. Yeah.
Thank you, ma'am. Yes, sir.
I have a very small question. Like you mentioned in your slides, there is a latency of 10 to 30 milliseconds.
Yeah.
What is the cause of that particular latency?
So when I talk about this latency, is I talk about the end-to-end latency. End-to-end latency means if I'm sending an information from this place to the or towards you, there's a laptop in between, there's a madam in between. So that laptop can be a core network, that madam can be a transport network. So if we don't have a lot of jitters, just an example on a transport network, my latency will go high. So we should have a more reliable, transport network. We should have a more, faster core network. That's how we can increase the latency. And in 5G, we are talking about 1 millisecond of with the standalone networks, but in 6G, we are targeting traffic in 3.1 millisecond. So see the difference, current networks which we see if we do a speed test, we will get a latency around 30 millisecond or so, or 45 millisecond, or if you depending upon where your system or speed test server is, depending on that, it can really vary. But think about now, 1 millisecond, 0.1 millisecond. That's how technology is. For that, that's why for that kind of latency we require this kind of phone. Because in NSS where we are getting around 30 millisecond. When we talk about SA, we can reach up to 1 millisecond because there we are giving a real 5G core, which is 5GC, and also we are upgrading a lot on. So that is how the equivalent latency is being calculated, and we are targeting 0.1 millisecond V6.
This is basically in the implementation of the protected network.
Exactly. So how we implement the algorithms, how we implement the other things, it depends on that.
Thank you, sir. Can you pass the mic on?
So as you just mentioned buzzwords, there is another buzz going on around might be in the same industry, Starlink. This might be a technology able to perform extra vision in front of Geo and Bharti Airtel. What do you have to say about it?
So I think they are not the competing technologies; they are the complementary technologies. Even recently, I think 1 week back, Starlink and Geo has both got the license in India uh, to to uh, to have the internet through satellite. So these will be more visible or applicable in the areas which are far from where we don't have the mobile towers, where the connectivity is a problem, where you don't have what the areas like hilly terrain and all. So they will target those areas because in those areas, putting aside or laying the fiber or even having a power connection there or electricity itself is a challenge. So those areas will be the target areas. Starlink can't provide you the internet connectivity within a dense urban area or a urban area. So market segment is different. So they are not the competitors for Jio or Airtel or any other mobile operator across the globe. So Starlink is new to India, but it is not new to US. They are already operating there. So there is no conflict of interest in both the, because their play field is different.
Thank you. Do we have any other questions there? Anyone? Okay. Can you pass on the mic back? Good afternoon, sir. So my question to you is, as you've explained about URLLC, so what are the major differences between the categories of 6G?
See, UNLCC is not only about 6G. Currently, we have features and functionalities in 5G also, by which we can deliver the UNLCC. In UNLCC, the main aim is to focus on the latency. In EMBB, the main focus is on the throughput of the speeds. What we do in UNLCC is suppose, uh, we are operating an GCP in a mine. So somebody is sitting remotely and operating a mine autonomously in a mine, and then so that the operator which is operating and the main machine is behaving, there should the latency or the time lapse should be very less or very low. So in ULCC we keep in mind we do implementation in such a way with respect to software that the latency is not compromised at any cost. Yes, we can might compromise on bit of throughputs or speed, but from a software perspective, we take care that we don't compromise on the latency part, and everything should happen in a real time scenario. So that is possible, still possible in 5G. 6G, there will be announcements, which I also don't know, to be very frank, because it's still very, very early stages.
Thank you. Thank you.
Sir, is CC going to provide green communication and sense?
Yes, definitely, because when we talk about 6G, we are talking about terahertz kind of frequency band, 6 gigahertz band and all. And apart from that, not only 6G, in 5G also, we are a lot of focus on the energy efficiency and sustainability. So we have a target to reduce the carbon footprint by 2030 by 60%. So this is how, industry is evolving themselves so that we can bring in more energy efficient features like we have sleep mode. Currently, if I have a big machine, say server, which is running on a 30 servers or 40 servers, from any company, and during for an example, in night times, I don't require all those servers to be on. What I will do is the system will intelligently, put rest of the servers in sleep mode, and typically they will make sure the servers which are essential to run those applications, the bare minimum servers are only on, and rest of the servers which can be switched off intelligently. So these kind of patterns will happen automatically through machine learning. They will see how it's happening over weeks and days, and based upon that, they can take uh, proactive actions in shutting off those servers or any other machines which is fully not in use, and they can save a lot of energy. Apart from that, we are also working on the hardware, which will be more energy efficient, consume less power consumption. Previously, when I started working, the power consumption of the systems on a small box was around, 1000 milliwatts. Oh, sorry, 1000 watts. Sorry. Now, similar systems are having, after 20 years, a power consumption of, say, 150 watts or 200 watts. So we are really working towards that level, and probably by 2030, we will see we will have a reduction in carbon footprint by 60%.
Okay, thank you, sir.
Thank you, sir, for gracing us with your presence and sharing your invaluable acumen. Let's continue. Your contribution contributes to the big for a brighter, more innovative future. Ladies and gentlemen, as we draw the curtains on this insightful and thought-provoking session of Amirtkaal Vimarsh, I stand here with a heart full of gratitude and appreciation. A sincere note of thanks to our esteemed speaker, Sir Deepak Soni, whose words have ignited our minds and inspired us beyond boundaries. Your wisdom and insights have added immense value to our discussion today. May I now request our Honorable Deputy Director and HOD of EC Department, Professor Rajiv Sharma sir, to present a memento or as a token of respect and appreciation to our esteemed guest, Mr. Deepak Soni. Thank you so much, sir.
Sir, sit down. Yes.
I extend heartfelt gratitude for the immense its presence here. Presence have elevated the significance of this gathering. Your support and encouragement are instrumental